You pour structural asphalt just 10 degrees too cold, and your entire roadway is doomed to fail before the first winter is over. In construction materials testing, guessing the temperature isn't just risky, it is an expensive liability. Today, we are breaking down why an infrared thermometer is your most critical tool on the job site, and exactly how to use our top 3 models to get perfect readings every single time. Welcome back to Certified MTP, your ultimate resource for material testing equipment and standard methodologies. When you are working with concrete, structural asphalt, or even monitoring the ambient temperature of your mud density apparatus, temperature control dictates the structural integrity of your final product. For years, technicians relied on probe thermometers. While those are great for internal core temperatures, they are slow, messy, and require you to physically touch the material. This is where the infrared thermometer changes the game entirely. An infrared thermometer allows you to instantly read the surface temperature of hazardous, moving, or unreachable materials from a completely safe distance. But here's the catch. Not all infrared thermometers are created equal, and using them incorrectly will give you false data. If you point a basic thermometer at a reflective metal screed or a steaming pile of hot mix, you might get a reading that is wildly off base. That is why today, we are giving you a simple, specific breakdown of 3 distinct temperature ranges, the exact tools you need for them, and the correct operating procedures for each. Before we dive into the specific units, let's quickly explain how to use this technology in the simplest terms possible. Every object emits infrared energy based on its heat. An infrared thermometer works like a camera. It uses a lens to focus that invisible infrared energy onto a detector, which translates the energy into an electrical signal, and finally into the temperature reading you see on your digital screen. To use any infrared thermometer correctly, you have to understand 2 simple concepts: distance to spot ratio and emissivity. First, the distance to spot ratio. Think of the thermometer's laser like a flashlight. The further you pull the flashlight away from a wall, the wider the circle of light becomes. If your thermometer has a 12-to-1 ratio, it means that standing 12 inches away from the material, you are measuring a 1-inch circle. If you step back to 24 inches, you are measuring a 2-inch circle. The biggest mistake technicians make is standing too far away and accidentally measuring the cold ground surrounding their asphalt sample. Always get close enough so your target fills the entire measurement spot. Second is emissivity. This is just a fancy word for how reflective a surface is. Rough, dark surfaces like fresh asphalt or concrete have high emissivity. They give off their heat easily. Shiny metal surfaces like the side of a compaction machine trap their heat and reflect the ambient room temperature instead. Keep this in mind as we walk through these devices. Let's look at our first product, the infrared digital thermometer with a range of -76 to 932 degrees Fahrenheit or -60 to 500 degrees Celsius. When to use it, this is your daily driver. For standard hot mix asphalt, which is usually placed between 275 and 300 degrees Fahrenheit, this range is perfect. It's also ideal for checking the heat of hydration on curing concrete surfaces or monitoring standard equipment engines. How to use it. 1. Power the unit on by simply pulling the trigger. 2. Identify your target. Let's say it's a fresh batch of asphalt in a wheelbarrow. 3. Step within 2 to 3 feet of the material to ensure your measurement spot is tight and focused only on the mix, not the metal edges of the wheelbarrow. 4. Point the single aiming laser directly at the center of the material. 5. Squeeze and hold the trigger. You will see the temperature update in real time. 6. Scan the surface by slowly moving the laser around the material to find the hottest or coldest spots. Release the trigger to hold the final reading on the screen. It is that simple. Next up, we have our extended range infrared digital thermometer. Reading from -76 up to 1,157 degrees Fahrenheit or 625 degrees Celsius. When to use it, you might ask, why do I need a higher range if asphalt only goes up to 350 degrees? In construction testing, you aren't just testing the end product. You are often testing the equipment, the drying kilns, heated aggregates for specialized polymer mixes, and exhaust systems on heavy compaction rollers. When your testing methodologies take you into these heavy-duty mechanical diagnostics, the standard 900-degree sealing isn't enough. You need the headroom this model provides so the sensor doesn't overload and throw an error code on the job site. How to use it. Using this unit is just as straightforward as the first, but with a specific focus on safety and technique. 1. Because you are dealing with higher temperatures, you naturally want to stand further back. 2. Calculate your distance. If you are standing 4 feet away from a heated kiln door, make sure the surface you are measuring is large enough to fill a 4-inch or larger circle. 3. Aim the single laser at the dead center of the heat source. 4. Squeeze the trigger and sweep slowly. When dealing with extreme heat, temperatures can fluctuate wildly over just a few inches of surface area. By holding the trigger and sweeping, the digital display will give you an accurate average of the thermal footprint. Finally, we arrive at the heavyweight champion of temperature testing, the dual laser infrared thermometer, capable of measuring from -76 all the way up to an incredible 1,832 degrees Fahrenheit or 1,000 degrees Celsius. When to use it, this unit is designed for the most extreme testing methodologies. We are talking about smelting processes, foundry work, extreme asphalt manufacturing plants, and deep kiln inspections. But the real star of this device isn't just the temperature range. It is the dual laser targeting system, how to use it. Standard single laser thermometers show you the center of the area you are measuring. A dual laser thermometer shows you the exact outside edges of the area you are measuring. Here is exactly how to operate it. 1. Grip the unit and pull the trigger to activate the dual lasers. 2. Aim at your target. You will notice 2 distinct red dots on the surface. 3. The space between those 2 dots represents the exact diameter of your measurement spot. If the 2 dots are 3 inches apart, the thermometer is measuring a 3-inch circle. 4. Adjust your distance. Step forward or backward until both laser dots are entirely inside the boundaries of the material you want to measure. If one dot is on the hot material and the other dot is on the cold floor, your reading will be ruined. 5. Once both dots are safely inside the target area, hold the trigger for 3 seconds to allow the high-capacity sensor to register the extreme heat and release to lock in your ultra-precise reading. Whether you are compacting a standard municipal roadway, checking the hydration of structural concrete, or running diagnostics on a 1,500-degree manufacturing kiln, guessing is simply not an option. You need precise, specific, and reliable data. All 3 of these infrared thermometers are built to withstand the rigors of standard construction testing methodologies, giving you the accuracy you need to pass inspections and ensure structural integrity. If you are ready to upgrade your testing equipment, check out the links in the description below to view these exact models on our website. Don't forget to hit that like button, subscribe to Certified MTP for more deep dives into material testing equipment, and let us know in the comments which temperature range fits your job site best. Stay safe, measure accurately, and we will see you on the next project.